will continue with the problems using Cauchy integral formula. Example, evaluate integral c z square plus 1 by z square minus 1 dz, where c is mod z minus 1 is equal to 1 using Cauchy integral formula. To evaluate this value, let us consider this integral first. Okay, we consider, and I will explain this. We consider the integral over c z square plus 1 by z square minus 1 dz. So this is our question. So this question, you see, denominator is of the form a square minus b square. What is a square minus b square? A plus b into a minus b. So this denominator can be splitted as z plus 1 into z minus 1. This 1 is nothing but 1 square, right? 1 can be taken as 1 square. So a square minus b square, a plus b into a minus b, z plus 1 into z minus 1. So now let us find the a values. Here you see it is bit different from the previous problems which we did. In the previous problems we have only one value in the denominator. One is a value. But here you have product of two terms. So you have two a values, right? Z values, or we can call it as Z value. So now let us find those Z values. Z plus 1 into Z minus 1 is equal to 0 means Z plus 1 is equal to 0, Z minus 1 is equal to 0. Either one of the term is 0, Z equal to minus 1 or Z is equal to 1. So now let us verify whether these points lie inside or outside the given curve. Okay. So usually using Cauchy integral, what we do? We know Cauchy integral is given by integral over c f of z by z minus a dz is equal to 2 pi I f of a if a lies inside c, right? So a means z. You can tell if z minus a is equal to 0, here z is equal to a, right? Z is equal to a. So this is our a value. Similarly here our a value is minus 1 and 1. So minus 1 and 1 will verify whether it lies inside or outside. So our question is curve C is mod z minus 1 is equal to 1. So now how to draw this circle here? So this circle, let me explain. Mod z minus 1 is equal to 1. So we know that mod z minus a is the general form, right? Modulus z minus a is equal to r, where a is the center and r is the radius. So here center is z minus 1, center is 1 and radius is 1. Okay, center of the circle, it represents a circle. Modulus z minus 1 equal to 1 is a, okay, this represents a circle, and this circle is of center 1 and radius 1. So let me draw the circle here with center 1. So this is our center point. Okay, center is 1. Radius is 1. Radius 1 means you can have 1 unit. Okay, you can have 1 unit this side, that is 2. It should touch as 2. You can have 1 unit this side. It should touch the point 0. This is 0 point, right? This is 0 point. So here either we can draw the circle like this with center 1 and radius 2. Radius is also 1. So 1 unit here. So it will be like this here. Similarly here also 1 unit. So circle will be like this. Okay, touching 2 and 0. So the point here, okay, point here is 2. This point is 2 and here it is 3, like that. So center 1, here it is 1 unit, here it is 1 unit. So now let us see whether this minus 1 and 1 lies inside or outside. So when you take z is equal to 1, you see z is equal to 1, 1 lies inside. Okay, z is equal to 1 lies inside C. Z equal to minus 1, it is a point is here, right? Z equal to minus 1 lies outside. Z equal to 1 lies inside. Z equal to minus 1 lies outside. So we can write Z is equal to minus 1 lies outside C. So by Cauchy integral formula, we have the condition like this. Therefore, we can write integral over C. What's our question is z square plus 1, z square plus 1 by z square minus 1 square, right? Z square plus 1 by z square minus 1 dz is equal to integral over C. So, we have some value when A lies inside C. When A lies, this point should be inside point. Okay, so we make an adjustment here. How we make an adjustment is, which is the inside point here, z equal to 1. So this particular point is z equal to 1 lies inside. Okay, here you see z equal to 1, it lies inside. So let us take this term to the numerator. Z square plus 1 divided by z plus 1. Let me write that here. Z square plus 1 divided by z plus 1 whole divided by, okay, so here integral over C whole divided by z minus 1. So this outside point is taken to the, this much together is taken as f of z, okay, divided by z minus 1, divided by z minus 1 dz. So what we have done, this inside point is, this is outside point, z equal to minus 1 lies outside. So that point is taken to the numerator, z is equal to 1 lies inside. That point you have to keep in the denominator itself. Now this is of the form, what is the form? Integral over C f of z by z minus a dz form. Okay, this is of the form f of z by z minus a. So whenever you come across a problem where one of the point lies inside and one of the point lies outside, you should follow this method. Okay, when denominator is in the product form, and if one of the z value is inside and one of the z value is outside, you take the outside value together with the numerator, keep the inside value in the denominator. Okay, inside value you keep in the denominator, outside value you take to the numerator. No change. If you multiply anyway, this is same as this equation. Anyway, that will come to the denominator. Z plus 1 comes to the denominator, right? So just an adjustment we are doing here. So there is no change in the equation or in the integral value. Just we are adjusting the term. We are taking this to the numerator so that if you simplify it, you can write in the same form also. So just an adjustment here. So now this is of the form f of z by z minus a. Now what is f of z? Now let us write f of z here. F of z is the numerator. Okay, f of z is the numerator. What is the numerator here? Z square plus 1 by z minus 1. And what is a value? A value is the denominator, you have z minus a, z minus 1. So what is a value? A value is 1. Okay. So now we can apply this formula, since integral over C f of z dz is equal to 2 pi a f of a. We can apply this, okay, by Cauchy integral formula. By Cauchy integral formula, our question is equal to, this is equal to 2 pi I f of a, because a lies it lies inside C, inside C. Now 2 pi a f of a. F of a means f of 1, because a is 1, we can write f of a as f of 1. Now how to find f of 1? We know f of z is, what is f of z? That is the numerator, right? You have that here. F of z is equal to z square plus 1 by z minus 1. So f of 1 is replace z by 1. So 1 square plus 1 by, so you get the value here as, okay, this is plus 1, okay, this is not minus 1, this is plus 1, here also plus, because numerator is z square plus 1 by z plus 1, z plus 1, z plus 1. So you get f of 1 is replace z by 1, 1 plus 1 by 1 plus 1, 1 plus 1 by 1 plus 1, that is 2 by 2, that is 1. Okay, so we replace, we substitute 2 pi I into What is f of 1? F of 1 is 1. So answer is 2 pi I. So our integral value is 2 pi I. Our answer is 2 pi I.